Cisco is a series sponsor of our ebooks on Docker and the container ecosystem. Learn more about Cisco's perspectives on these timely and important topics in our latest ebook about application architectures and microservices. It's available for download at thenewstack.io. Alex Williams here of The New Stack, here with Ken Owens. We're here at OpenStack Tokyo. This will be published sometime in the future, but for now, this is where we are. And so, Ken, I wanted to just talk a little bit about microservices and some of the trends that you're seeing there, and what customers are asking about and what they're needing and requiring to build out these microservices platforms. So perhaps maybe one of the first questions is, what is driving interest among customers in microservices in general?
Yeah, hey, thanks, Alex. Nice to be here and love Tokyo. So it's always fun to be in Asia. So there's sort of a journey that enterprises have been on for some time. And I kind of look at the trends in two different areas. So the one area is, if you think about IT today, is a lot of complex systems and very complicated processes around these systems. And those systems were designed over many years and over a lot of different use cases and design requirements, right? And what has happened in the last several years is IT has tried to simplify those complex solutions by kind of automating the infrastructure. And what automating the infrastructure has done is made it faster to get environments set up for testing and development to happen, but it's still separate from production environments. And so developers are still faced with, how do I kind of connect together these different disparate systems? How do I connect to like the OSS and BSS systems that are not part of the infrastructure at all, right? Completely separate systems. How do I deal with like the InfoSec policies around security and governance? And so while the complex system design to kind of automate the infrastructure has helped infrastructure deliverers, it hasn't really helped the developers at all, right? At the same time, on the other end of the spectrum, you have developers just saying, I'm going to go, the businesses developer go off and build the solution as fast as you can, and they go off to Amazon or go off to some other environment and just publish an application as fast as they can, but then they have no way to connect that back into their internal systems to be able to support it or to bill for it or to manage it, right? Mm-hmm. And so with these two extremes, you're kind of left with two very complex problems to try to solve, which is, how do I integrate these systems together? How do I create a process that lets me develop my application and deploy it and manage it and run it? And so what microservices has done is it's kind of taken those complex designs and said, let's create components of this system. Let's create an OSS container. Let's create a BSS container. Let's create a test, dev, and production environment that allows these containers to be deployed across these different environments in the same manner. And if you look at it from that standpoint, what containers and microservices has done is it's really allowed the developer and the infrastructure teams to work closer together to create a joint solution that runs in their internal development environments and runs in the test and QA and production environments in the same manner that developers test it against.
So talk about the process of breaking things down to get to the point where you actually can start putting things in containers.
Yeah. I think there's a major misnomer in the industry that these monolithic applications can never be containerized or can never be made cloud native. That you sort of have like two separate worlds that can never coexist, right? And the truth is that when you look at the problem from an application architecture, there are components of every application that are kind of monolithic in nature and may be for some time. And I think that's acceptable given the constraints that our systems have today, right? If you can't really take a monolithic operating and systems, kind of like a ticketing system, and say, I'm going to containerize this ticketing system today, right? But there are pieces of that application that are very much containable, right? Things that have to do with queuing of the application, things that have to do with the services like DNS services and networking services, security services, aspects that are around the application architecture that could be containerized. Maybe not the database as much today, but definitely the application architecture can be containerized.
So one way that we've been talking about it internally is, with microservices, you essentially have a communication network, right? You need to have the communication among the people,
Right.
so you have a common understanding of what you're doing. That's
Yep.
the first part. The second part is the service discovery, right? Like, so people know what the services are available, what they can integrate, and what
Right.
they can, implement.
Yep.
And then the other component is that scheduler capability, right?
Right.
So this scheduling things, to be able to see, these different small groups are working independently, but you can see what's coming down,
Exactly.
what's coming down and what's working,
Right.
or where support is needed, and so on and so forth.
Yeah.
Is that approach becoming standardized at all, or is it still very much a very fluid, organic type of thing? Are we starting to see the practices emerge around microservices, and if so, what are they?
Yeah, to date, it's pretty much each individual business is creating their own set of orchestration, their own set of scheduling solutions. There's some containerization, standardization happening within the Open Container Open Container Foundation. That Google and Cisco and Red Hat and a few others are kind of sponsoring with Docker. You have
For the spec and the runtime.
for the spec and the runtime,
Right.
but still not everything that is needed to kind of build a contained microservices infrastructure, right? There's work in the open source community that Cisco is doing with Mantle that is trying to provide sort of that initial framework of here's an end-to-end orchestration flow, here's an end-to-end set of tools and services that are built on open source components. Leveraging things like HashiCorp's tools like Consul and Terraform. Terraform gives you that kind of what I kind of call the infrastructure as code environment, right? You can kind of create an overlay that connects to any cloud, pretty much any cloud type of solution. When you're looking at Mesos, so open source Mesos and Kubernetes as sort of the scheduling of those workloads. And then Consul is sort of a way to package those components together for service discovery and service publishing. And so there are different tools out there, and I think eventually you'll see the industry merge to kind of a common set of services. We think Mantle is kind of one piece of that can help drive the standardization effort down that path. The other piece of that you mentioned that's interesting.
Tell us more about Mantle before we go into that other piece.
Sure. So Mantle is an open source solution that allows you to kind of look at the developer use case from three angles. So the first one is the build piece, and I have a philosophy that developers shouldn't have to change the way they develop. Whether they're developing a monolithic application or a cloud native application, the way they write their code, the frameworks that they use to write their software in, shouldn't have to change just because
very
they're moving.
unopinionated.
Very unopinionated, right? And very extensible as well. So as new, like we support Golang today, so as new coding methodologies evolve, being able to add a framework in is very important to us, right?
Is that new? Well, Go is relatively new anyway, but how new is that support for Golang?
It's been in place for about a year.
Okay.
Yeah.
So why did you decide to support Golang? Is it because I would guess it's the direction of the Docker container ecosystem.
Yeah, that's one big part of it. The other part of it is developers love Go.
Right.
As soon as they start testing and using Go for any of the projects, they just love the language.
Okay.
And so it seems to be kind of the de facto new emerging standard for development.
Okay, so back
Now,
to Mantle.
that may change.
Okay.
But right now it
Yeah.
seems to be very popular.
So back to Mantle then,
Yep.
carrying on with your perspectives there.
So that's the build piece.
Yeah,
The next piece of the process then is to deploy.
right.
So once you've built your code, the promise of containers is application portability in a sense, right?
Right.
You can develop your app once and then deploy it anywhere.
Right.
That has not really happened until Mantle, right? So with Mantle, we let you take that code you've developed and you can now deploy it into, we support Amazon, Google, Compute Engine, DigitalOcean, Azure, VMware environments, and OpenStack environments. And so now you can basically deploy that code to any place that you have a cloud account. And it doesn't, and from Cisco's standpoint, being anti-lock-in is important because you want to be able to write your code to deploy into any environment that makes the most sense based on your business needs, based on the location of your customer base, based on the performance at that given time. So we're adding performance pieces I'll get to later, but we're adding things to help do application policy to make sure that your application is always up, always available. You have so many instances of it running at one time, right? Things like that will allow you to kind of make the best price versus trade-off of flexibility and security and reliability that you want to make for your business. Okay. So that's the deploy piece. And then the last piece is run. So having the visibility of the application, not just the underlying infrastructure, which everyone has, right? And you can go out and buy like a high-end APM tool and manage the application performance at the very high-end level. What we've kind of focused on is what I kind of consider to be the sweet spot for a developer, understanding what's the underlying performance of the platform that they're running in and their application behaviors across these different environments. And so as an example, if you've deployed 25 containers across 4 different clouds, how do you manage all that as a single application instance? And we've kind of taken the visibility of that as an application instance that you can see the underlying containers and where they live. You can see the performance and the processes that they're spawning off, how they're performing.
So that speaks to the underlying compute, and I know you guys have been active in the Mesos community. What is that underlying compute? That seems to be a major factor here to create that programmatic infrastructure.
Yeah. So the underlying compute, we've sort of abstracted what the physical interfaces are, because I'm a firm believer that you don't want your developers writing to an infrastructure API. Infrastructure needs APIs, right? APIs are good for the infrastructure. But what you want with microservices is to kind of create an abstraction layer that you don't have to write to that specific compute API. And so if you think about the clouds I mentioned, right, you have AMIs with Amazon, you have Google Compute with GCE, you have Neutron and Nova with OpenStack, and you have NSX with VMware. And so with all of those different environments, you don't want your developer to try to figure out, okay, which API do I need to talk to in these individual clouds? Right. So we've kind of abstracted all of that as a set of network services, compute services, and storage services that you would write to as if you were writing to a generic driver for compute.
Okay.
And then underneath that, right, if it's a Cisco UCS, there are things we can expose that would allow you, if you care, that you have UCS under the covers. You could do specific things with compute profiles that would give you higher performance, right? But we don't force you to understand that there's a UCS under the covers. But if you want to, it's there for you to use.
Right.
Same thing with like NSX. We can expose NSX features if you want to take advantage of those SDN features.
Right. So there's that cross capability that you need to have. You talk about the build, run, deploy, aspects of microservices. Let's get down into a little bit of the more nitty-gritty and talk about, for instance, these different services, service discovery environments, and what are some of the considerations there that people should be thinking about?
Sure. I think the number one area of focus for sort of these service delivery environments is understanding the amount of what I like to call sort of the availability, the amount of security controls that are in place, and then what are the access rules to allow someone to access that environment.
Right.
And so when you think about service discovery, services in and of themselves need to be secured.
Right.
And so when you think about how do you want to connect to a service, or how do you want to register for access to a service, you kind of want to look at what's the requirement for authenticating that I am valid requester of that service, and then when I receive the service, how do I validate that service is what I asked for, and it's not some other service out there that just kind of hacked into this network, right? And so that to me is probably the key problem that needs to be solved in the whole service discovery, service assurance.
The authentication.
The authentication of those services and the requester of the service.
Do registries help with that?
They do.
Yeah.
Yeah, and also the other thing that helps with that is kind of a security password type of mechanism, like Vault. HashiCorp's Vault's a good example of something we've been working with that allows you to kind of create a key store that's encrypted and secured off to the side. Put your encryption keys into that, and then you're just passing keys to a service. You authenticate that service with the key they pass back. It's not quite public-private keys, but it's a very similar infrastructure.
So with those service discovery platforms, one of the things you really want to look at are the authentication capabilities for
Right.
it,
The availability of it.
the availability of it, and the authentication, I guess, speaks to that.
Right.
How do you manage?
Well, a good example of the availability, concern or aspect is, as with everything that happens in cloud, right? Once you create a new service, you now are dependent on that service being available,
Right.
Whether you call it the control plane versus the data plane, or whether you
Right.
consider it kind of a aspect of the data plane is irrelevant in, I think, the concept, right? The concern is if I'm requesting a service and my way to request that service is down, right? The response of that request, or the bus that I'm connecting to, isn't taking requests at that time, then I can't spin up additional services or manage my services because the publishing bus is down, right? Or the response to that publishing bus is down. And so as you pick a technology around that, like, we're using Kafka, but as you pick a technology around that bus, the availability of that bus and the assurance of that bus becomes very critical to everything that those developers are going to try to request and get access to from that point on. And so it's one of those design pieces that no one really thinks about right now, but it's very critical because if that bus goes down, you can't request any new modifications to any of your existing services.
That speaks to the rethinking of what we have known as infrastructure and virtualized infrastructure.
Right.
Because if the control plane or the data plane, whatever you want to call it, is distributed, now we have a much different set of requirements,
Right.
which speaks to the importance of that to think about in microservices, doesn't it?
Yeah, it does, definitely.
So with that in mind, the services environment, and I think in future conversations, I think we can talk about, this is where I think the issues around networking and storage come to be kind of clear considerations here. Let's talk a little bit about the scheduler requirements, and then maybe we can conclude it by thinking about kind of like the way I'm starting to think about the stack is almost like a graph, right? So tell us some of those, so we've talked about the service, the service discovery capabilities. Tell us about the schedulers and some of the kind of the tenets, the foundations of a scheduler that we're starting to see.
Yeah, so to me, scheduling is probably if you were to kind of look at the parts of the system that are important, I would say that scheduling is probably the most important part of this system, right? And some of the schedules out there, and they have different capabilities, but the most standard ones are around Mesos, which usually has like Zookeeper and Marathon to kind of help with the aspects of scheduling that's needed to kind of keep track of all the different systems. And then you have Kubernetes, which is really more for sort of the data science, higher performance, higher speed schedulers. To me, the core pieces of that have to do with what's the architecture for that control of that scheduler, what's the data architecture, or kind of what we like to call the service nodes, where you have the control node and the service nodes. What does that architecture look like for a highly distributed system? And so it becomes very important to think about the distribution of those core components of the system, as well as those individual nodes that get deployed with every application service that you deploy. The second piece that's important with the scheduler is the job scheduling itself, right? The function of scheduling those jobs and the efficiency and the way you optimize those scheduled performances is very key. And so there's a few parameters you can tweak with the schedulers. One has to do with kind of the frequency that the bus operates at, if you will. The other one is around the availability of those requests. And so you kind of have to, the more you pump up the performance, the more that availability becomes strained because you're pushing a lot more through the system. And so one of the things that we've looked at doing and have implemented is we have a minimum of 3 control nodes per set of like 6 main service nodes. And so that way you kind of have a 2-to-1 ratio of if one service goes down from a control node standpoint, you have 2 other services immediately processing whatever failed as you spin up a third service again. So it's always a minimum of 3. As your performance increases, we scale up more and more and more of these control nodes based on the performance of the underlying bus itself. And so we're still tracking and scheduling that with using actually, believe it or not, Manaska, which is a new OpenStack project that my team is leading that kind of takes Alaska and Manaska and combines them together to give you app performance monitoring.
So it's a performance monitoring
Correct.
capability.
And it's kind of infrastructure, so it's very good for the bus, the Mesos bus and the Kubernetes bus. So it's really good for that underlying architecture of those two scheduling platforms. So as you need to scale up your services, we can scale those up automatically. But there's always a minimum of 3. So if you lose one, you have the 2 additional ones still working.
So that, with that in consideration, the understandings of a microservices environment really speaks to the need for lightweight services. So what do you say to companies who are trying to think more about developing microservices that have had virtualized infrastructure for a long time?
Yeah. To me, there's 2 types of enterprises to consider microservices. One is what you just described, the virtualized infrastructure. In the case of VMs, a VM typically equaled a server in the old world, right? And so you'd map a server to a VM, and you could put multiple VMs on a physical server. You take a physical to a virtual mapping, right? For those enterprises that did their mapping in that way, you're still not ready for microservices with just that VM. You have to take that VM and break its services into individual components. And so you have to take out the application pieces, take out the database pieces, take off any web front end pieces, any app tier pieces. And each of those individual stacks becomes a separate microservice. And so a single, end tier application could consist of 5 or 6 microservices in the end. If you think about like a 3-tier, you might have like 4 for the app, a couple for the web, and then 1 for the database, right?
Okay.
If you think about the other aspect of the enterprise that sort of took advantage of virtualization to truly separate their VMs into separate services. Maybe not. They might not have called them services at the time, but they might have created a web end and a back end and a front end so if they kind of broke it into those smaller pieces, so one physical server equaled 4 or 5 VMs, you're much closer to the microservices way of thinking. You still probably have to separate those a little bit further, but you're not quite as far from microservices at that point because you already kind of thought through, I'm going to take this physical box and make it into separate virtual boxes so that I can separate these dependencies from each other.
So you guys must be developing the skills to actually see these, right?
Yeah.
So like you go into an environment and say, oh, this is definitely in this camp. This is not not the group that was like thinking about clusters of VMs. Right?
Exactly.
Yeah, interesting.
The other thing that is interesting in this use case is there's a lot of you probably know the statistics better than I do, but I think they say around 90% of enterprise applications have been virtualized.
Sounds
right?
right.
And so for that other 90% that would that other percentage you're trying to get to that aren't virtualized, I think containers can give them a way forward, and they can bypass the whole virtualization piece because virtualization does have attacks, right? There is overhead when you virtualize. Managing that virtualization layer is just another layer of complexity to manage, right? And so the nice thing about containers is they run on bare metal. You don't have to have a virtualization environment to run containers. And so I think for a lot of those enterprises that didn't want to deal with the tax of virtualization, didn't want to deal with the headache of virtualization, or didn't have just the IT staff that wanted to deal with virtualization, this gives them a way forward now because they don't have to deal with the virtualization piece. They can just go straight to containers and run it on top of their infrastructure as it is.
Well, so when we publish this podcast, it'll be January, and we're here in end of October of 2015. What do you see happening to our concepts of what a stack really is? And because one of the things that I want to conclude with is this idea of the control plane, and the relationship to microservices platforms, and the concepts that we are starting to see, almost like these floating elements, right? That are finding places to connect with each other.
Right.
So what I'm curious on your perspectives on that, just kind of looking out, over the next 12 months or so.
Yeah, I believe over the next 12 months that the concept of infrastructure as we know it today will be completely different. You still have virtualization, you still have OpenStack and VMware. You're not going to get rid of what's here today, but I believe the conversations you'll be having with your customers, I'm having with customers, will be more around this, as you call it, the kind of the microservices infrastructure layer. Like how do you orchestrate services? How do you connect services? How do you write an application that is agnostic to the underlying infrastructure? And the control plane for doing that, and how these services connect together, with things like the cloud foundation, the container foundation work that's going on, in
cloud
just
native
industry.
computing foundation, OCI.
Right. Yeah. With these different standardizations coming together, and with the microservices involvement, evolving as fast as they are, I believe the whole conversation will be around the new stack of orchestration, around scheduling, around application portability, and how do you develop your applications in a way that you can break down these different aspects of your application into self-organized containers that can be distributed across multiple environments.
Well, great. Well, Ken, great to talk to you as always. Thank you for spending some time with us, and again, we'll be talking again soon.
Great. Thanks for having me, Alex.
Thanks.